Yes, I studied science. Physics, specifically. I'm a big fan of it as well. Really, I love it. I had 2 friends of mine from my physics class went to Oxford. And one of them's real big into physics. One of them was also into physics, but like this guy was like really big into it. And we used to have talks about like really theoretical physics and stuff. And one of my why sticky keys popped up. What's all that about? Anyway, one of my favorite conversations we ever had was he liked all these like outlandish theories, and he really liked the theory that the whole universe was a simulation, right? And it's like, you know, it's believable. Like, the more you think about it, the more it's quite believable. And we were thinking about all these weird like weird phenomena of physics that like can't really be explained. Like for example, what's it called? God, it's been so long. What is it when something's both energy and mass? Oh, of course. Don't. Right. You can trigger warning it with derealization, but here is my attempt in trying to say it does not matter whether everything is simulated or not. You're as real as you possibly can be. All right. Whether this whole universe is ran within a computer, you are very much real within it. All right. You know. Like that's, if it bothers people, by all means, feel free to tune out of this bit. But the whole universe being simulated and the whole universe not being simulated makes no difference in how real you are, right? It's like that's not a thing. That's not what I'm trying to argue. I'm not trying to argue that we don't exist. We exist, right? That's not part of the argument. The argument is, does this exist in a calculated medium like a computer? And my friend, so there's this phenomena in physics where essentially matter, everything in the universe can either so they tell you matter cannot be created or destroyed, and the same with energy, right? And that's strictly not the case. You can destroy matter and you can create energy, but from each other, essentially meaning that energy and mass are interchangeable. There's a set amount of energy and mass in the known universe, in the whole universe actually. There's just a set amount of the stuff. And it's interchanged. So if ever something becomes less massive, it is transferred into energy, right? Meaning that's how things work. So, what we were arguing about was why does the phenomena of... so what happens? This is what I don't know why I'm giving you a lesson on this. I'm probably going to lose some of you viewers, but I fucking love this topic. Essentially, this is so dumb. Essentially, there's this phenomena where if you diffract electrons through crystalline structures, you can get diffraction patterns. You can get diffraction. Matter can't diffract, all right? Mass cannot diffract. Energy, like waves can. Waves can diffract. Essentially meaning that we can prove that electrons, which are a physical thing, act as waves, okay? However, this only... Wave particle duality, thank you. I couldn't think what it was called. However, all right? This is the best part. This only happens when you don't watch. If you watch, it doesn't happen. Right? How insane is that? This is what the part I love. It only happens when you're not watching it. Right? If you actually physically use a microscope to watch the electrons pass through the hole, the diffraction doesn't happen anymore. But when you don't watch them, they act like waves, right? How the fuck does that happen? I think the answer is we actually do not know, right? So me and my friend liked to come up with our own answers to these questions, okay? And we were like, what's this all about? And we basically, his conclusion, bear in mind he's an Oxford student now, his conclusion to this question was that we are a simulation. And you know how, like, in Minecraft, when you're not looking at a map, it de-renders, and there's just kind of a computer placeholder that goes, when you look here, there should be a map, but I'm going to unrender the map because that's just efficient for memory, right? He's like, what if, when we're not looking at things, it's just energy to save on RAM? And, like, quantum so that was his, like, it's like, okay, I'm in water, and that's not very good for me right now. And then, so yeah, like the world, like, so like that, you know, like that's memory efficiency coded into our little universe. And then, quantum entanglement. So quantum entanglement, this is both advanced computing and physics. This is going to get quite, not that advanced, but it's like, you need to know a little bit about both, to get this. So I'm going to try and explain both. But, I can't remember if it was me or him that came up with this one. I think we used to speak about all sorts. But one of us came up with the idea that quantum entanglement, which is just a really big word, I get. But quantum entanglement is, in essence, where two, it's usually subatomic particles, so usually it's quarks, are interlinked, meaning that the state of one is affected by the state of the other, right? Forever. They can be millions of miles apart. You can, with 100% certainty, say what's going to happen to one by understanding the other, right? These are particles that are completely linked, okay? That's essentially what that means from what I understand of quantum entanglement. If I'm wrong, let me know. But that's essentially what I understand to be true. Thank you for the 10 gifted, dude. So that's what that is, right? So that's quantum entanglement. And we were like, they're soulmates. Yeah, like soulmate particles, exactly. Like they're like particles that are smaller than atoms. Which, yeah, that's a new thing. Some people don't know that. It goes smaller than atoms. We go further than that. It goes, so you got atoms that are made up of protons, neutrons, and electrons. And then protons and neutrons are made up of quarks. And quarks are, there's a word for them. There's a word for them. They're basically, they don't go no smaller. They are like, that's what it is. So, anyway. Yeah, the particles are in love, and they're completely affected by each other, regardless of wherever they are in the universe. They that's how they work. So anyway, that's quantum entanglement. And one of us decided that in computing you can get what's called buffer overflow, which is essentially where every program that runs on a computer's memory, it kind of just goes, I want this much memory. I'm having it, and like takes so much memory. But what can happen is if you fuck up your buffers, when you open another program, you can have two programs open. Say there's a so let's I can show you in Minecraft. Oh my god, I'm being educational. Right, watch this. Okay. This is RAM. Okay. This is RAM. Okay. So, this is RAM. This is a stick of RAM, okay? And all of a sudden, I want to stream. So I'm opening OBS, right? So like I open OBS, and now OBS inhabits like this much RAM. Like OBS has went, this is mine, and that's what OBS has, right? So next thing you know, I boot Minecraft to play the Dream SMP, and that is taken up by this much. So this is the Dream SMP, and this. Let me kill these mobs. So that's the Dream SMP. And that's, wait, let me kill these guys, I'll tell you. So this is OBS and this is the Dream SMP, right? All of a sudden, fucking Phil raids and I get a bunch of new viewers, and since I have my chat open within OBS in a plugin, there's plenty of more chat messages going in, and it's expanding into RAM. That technically doesn't make sense, but whatever, right? All of a sudden, if OBS was coded really shittily, instead of going into free RAM, it might just accidentally go, all right, let's just take up some RAM. And all of a sudden, it's now leaked into what Minecraft was using. So now Minecraft now goes to grab like a little bit that was in this bit of memory, and all of a sudden OBS is in there, and Minecraft just fucking breaks. All right, because it basically, what I'm saying is, that's a buffer overflow. What is happening in OBS is now in Minecraft, what Minecraft believes to be its memory, and it makes it do peculiar things, right? That's how it works. So, this is where quantum entanglement comes in. If the universe is simulated, you can explain quantum entanglement by simply saying that the two quantum entangled particles simply are sat next to each other in RAM, and due to small buffer overflows, what happens in the memory of one is read by the other, affecting its state. Does that make any sense? That was our theory. That was what we sat down and came up with. That was our like game theory as to quantum entanglement. If the universe was a simulation. I need to like hold myself in to like eat because I'll die otherwise. But yeah, that was our little game theory. So that's what we came up with. Maybe that doesn't make sense. At the end of the day, we were A-level physics students who just kind of went off of what we knew. But that was what we thought. I think it's really cool. It's one of my favorite. That's the manifold theory of quantum entanglement.